you'll notice that in all the problems that we've done so far with integration by parts, there haven't been limits of integration. So let's consider a problem like the following. What if we wanted to integrate x times the sine of x with respect to x, but we wanted to do it from, say, 0 to pi? So we now have limits of integration, right? And our formula did not have limits of integration in it. Remember, our formula for doing this was the integral of u dv is equal to uv minus the integral of v du. Okay, so no limits of integration there. This just doesn't work with limits of integration, all right? Because you're doing a double substitution. You're letting u equal something, and you're letting dv equal something else. And these originally were probably limits for x equals a to b. So when you integrate, it's going to be a big mess because of the double substitution. So what you want to do is ignore the limits, find the antiderivative, and then use that the integral from a to b of f of x dx is equal to f of b minus f at a. So our strategy is just find the antiderivative and use it to get the answer. Okay, so for instance, in this problem that we have, we already know that the antiderivative, we did this in a previous video, of x sine x dx. It's a classic example to do by parts. The antiderivative is negative x cosine of x plus sine of x plus c, if we want to have any antiderivative. So then if we want to figure out what the integral is from 0 to pi of x sine of x dx, we can simply take the antiderivative with c equal to 0, evaluate it at x equals 0 and pi, and substitute those values in. So what does this equal? This equals, we put in pi, we end up with negative pi minus the cosine of pi. All right, plus the sine of pi. Oh, I'm sorry, there's a mistake in here. I couldn't read my own writing. That's not minus cosine of pi. That is times, that's a dot. So that is a dot, not a minus sign. Okay, so that's what happens when we substitute pi, and we're going to have to substitute the 0 in. But when you put 0 in for x, the entire first term goes to 0, and then you'll have plus the sine of 0, which will also be 0. But let's evaluate each thing now. Negative pi. The cosine of pi is negative 1. The sine at pi is 0. Okay, minus 0 plus 0. Okay, the sine of 0 is 0. So we end up with an answer of exactly pi. Okay, so that's nice. But let me just highlight what I did here. Because of the double substitution, you don't want to try to change the limits like we had done before when we had u substitution, and we would make a little table of x versus u and put the a and the b in and translate those into their values for u. You don't do this anymore because there's a double substitution. Just find the antiderivative. For this, we have found the antiderivative in a previous video, and use the fundamental theorem of calculus with that antiderivative to get your answer.